Hello friends, you are welcome to this tutorial. We are going to talk about the second and third generation of computers. With objectives. By the end of this lesson, you will be able to tell the features of the second and third generation of computers. Identify a transistor, identify integrated circuit, all known as the IC. Tell the difference between second generation computers and third generation computers. Let's start. First of all, the second and third generation of computers. Second generation computers were based on transistors. I don't know, have you seen a transistor before? No, okay. I guess most of you have seen a transistor before, but I'll show it to you in this tutorial. We're going to learn about transistors and IC, which are being integrated circuit used in the third generation computers. So we're saying that in the second generation computers, they were based on transistors. Essentially the same as first generation computers, but with the transistors replacing the vacuum tubes. I taught you in first generation computers that they use vacuum tubes. And these second generation computers are now using transistors. Okay. Now the third generation computers use printed circuits. So that's the IC, the printed circuit board, to replace much of the wiring between the transistors. This had the advantage that components could be mass produced, making the component board replaceable. So this time round, they use transistors, and it makes their work more easier than previously, that they were using vacuum tubes and they were using things that make the work difficult because of the wiring. This time around, they don't do much of the wiring in the third generation computers. They use the IC, they use the integrated circuit, which is some small device, and it has a lot of or millions of transistors built in it. You'll be seeing the picture shortly. Now, transistor. This is a transistor we're talking about. This transistor comes like this, and usually with 3 poles like this. One is the receiver and one is the emitter. So we have the controller at the base and then the emitter. Good. So we usually come with 3 poles. A transistor is a semiconductor device used to amplify or switch electronic signals and electronic power. It is composed of semiconductor material, usually with at least 3 terminals for connection to an external circuit. So as I was saying, it comes with what? 3 terminals. The first, the second, and the third comes with 3 terminals for connecting to an external circuit. So if you have the circuit board, these terminals are used to connect to that circuit. You may see a motherboard with systems built on it. So these terminals that they used to build on the motherboard. And so let's see, how do the transistors work? First, saying that transistors can serve as an amplifier and can also serve as what? A switch. Let's see transistors as an amplifier. How transistors work. When it works as an amplifier, it takes in a tiny electricity current at one end. And so we have a small device like this. We have the terminals. So this time I will say if it is working as an amplifier. I hope you know what an amplifier is. An amplifier, like let's talk about you using a microphone in the church or using a microphone somewhere. And you talk, the sound goes into that amplifier. And the amplifier amplifies the sound and make it louder than you usually made the sound. So the amplifier is something that amplifies anything that goes in it. So it's a computer system. This amplifier, we saying that transistors serve as amplifier means when you put in a current, electricity current, this one receives the current and then amplifies the current here and then put it out as a very big or more than the amount of current input. So it amplifies the current. It makes it a tiny electricity current at one end, that's an input, and produces a much bigger electricity current as an output at the other end. So this is what I'm trying to draw here. So we have the input, small electricity current, and it will boost electricity current to much bigger power. So it's serving as an amplifier. Good. It's a kind of current booster that comes in really useful in times like hearing aids. One of the first things people use transistors for. A hearing aid has a tiny microphone in it that picks up sounds from the world around you and turns them into fluctuating electricity currents. These are fed into a transistor that boosts them and powers a tiny loudspeakers, so you hear a much louder version of the sounds around you. Good. That was what I was trying to explain using the church or you singing with a microphone. The sound goes in it and then the amplifier boosts the sound and you hear it bigger than the one that is usually around you. So that's how the transistor works as what? An amplifier. Now, let's see the transistor working as a switch. Some transistors working as a switch. Transistors can also work as switches. A tiny electricity current flowing through one part of the transistor can make a much bigger current flow through another part of it. It also works. In other words, the small current switches on the large one is essentially how all computer chips work. For example, a memory chip contains hundreds of millions or even millions of transistors. Each of these can be switched on or off individually. So what we are trying to say here is that transistors working as electric circuits is talking about zeros and ones. So zeros and ones means true or false. I earlier discussed in how computers work that they are binary, and when we say binary, it means for zeros and ones, only two. So it can be what? 0 or 1. And when you type in a letter like 1 on the computer don't see it as 1, but it rather says 0, 0, 0, 1 in binary. And when you type into the computer says 0, 0, 1, 0. When you type in 3, the computer says 0, 0, sorry, no, the 3 is 0, 1, 0, 1, 1. Yes, that's 3. So this is 1. When you type in the computer, we see this one as 1, this one as 2, and this one as 3. So 3 is 0, 0, 1, 1. Good. How do I know this? No, this is binary. So it's programmed that anytime the computer you see this 0, 0, 0, 1, it means 1. When you see 0, 0, 1, 0 means 2. When you see 0,